This is part one of Mercury. We start with the key question. Mercury overview. Mercury is the closest planet to the Sun and one of the least understood worlds in our solar system. This series is an attempt to start fixing that. Welcome to Orbital Dispatch. I'm covering Mercury across a short run of episodes, beginning here with the fundamentals. What this planet actually is, how it moves, what's inside it, and why getting a spacecraft anywhere near it has been so difficult. Act 1. Setting the scene. On average, Mercury sits about 77 million kilometers from the Sun, but that figure shifts considerably because its orbit is one of the most elliptical of any planet. At perihelion, its closest approach, the distance drops to around 46 million kilometers. At aphelion, the furthest point, it stretches to roughly 70 million. That elongated path has real consequences for conditions on the surface, and we'll get into those. Mercury is small, about 4,080 kilometers across, not much larger than our Moon, which measures around 3,474 kilometers in diameter. It's the smallest planet in the solar system. Surface gravity runs at just 0.38 times Earth's, meaning an 80-kilogram person would weigh roughly 30 kilograms standing on it. Act 2. What we found. Here's something that catches a lot of people off guard. Despite being the closest planet to the Sun, Mercury is not the hottest. That's Venus. The reason comes down to atmosphere. Mercury has almost none. What it does have is called an exosphere, an extremely thin envelope of atoms, mostly sodium, oxygen, and hydrogen, kicked off the surface by solar wind and micrometeorite strikes. It can't retain heat. The temperature swings that follow are extraordinary. The sun-facing side can reach around 430 degrees Celsius. The night side falls to roughly minus 180. More than 600 degrees of range on a single planet, and no weather, no wind, nothing to moderate it. Only 2 missions have ever gone there directly. Mariner the 10 made 3 flybys between 1974 and 1975, producing our first close images of the surface. Then Messenger, launched in 2004, became the first spacecraft to actually orbit Mercury, wrapping up its mission in 2015. Among its findings was confirmation that Mercury has a remarkably large iron core, estimated to account for around 85% of the planet's radius. That's unusually substantial, even by planetary standards, and scientists don't yet have a fully agreed explanation for it. A third mission is currently on its way. Bepi Colombo, a joint project from ESA and JAXA launched in 2018, is expected to enter Mercury's orbit in 2026. It'll give us the most detailed look yet at the planet's magnetic field, internal structure, and surface chemistry. Act 3. Why it matters. Mercury matters for a fairly specific reason. It sits at an extreme end of what the early solar system could produce, baked by intense solar radiation, almost no protective atmosphere, and an interior that doesn't quite line up with how our current models say rocky planets should form. Studying it puts pressure on those models, which is exactly what you want. Getting Mercury right gives us a sharper picture of how Earth, Mars, and Venus ended up the way they did. Think of it as a reference point, a small, ancient, stripped-down world that's been sitting close to the Sun for over 4 billion years, largely unchanged. Next episode, we look at the surface itself, and why it holds some of the clearest records of what the inner solar system looked like in its earliest period. If this kind of planetary science is worth your time, subscribing keeps these episodes coming. See you in the next one. That is part 1 of Mercury. In part 2, we explore the next key question. Subscribe so you do not miss it.